Hello fellow AGD coders, welcome to another video, and this one, as you've seen, is a kind of two-in-one video in which I'm going to show you a way that we can reserve code space for adding additional machine code routines in a fixed position, and then I'm going to look at implementation of that using the color code, the new sprint command that I've added, which allows you to have the sprites with different colors without them painting over the backgrounds. So the first thing to say is the normal way to do this, of course, is to add code into the character set in here, and the advantage of that is that it's in a fixed position, so it can always be called at the same place, and it saves itself when you save the game. But the problems there are that you may want to use the characters for other purposes, and in addition, if you've got longer code, anything longer than say 200 or 300 bytes, you're really going to run out of space because there's not a lot of room there. So we're going to look at an alternative to that in a second. Before I do, I just want to let you know that I've also changed this pointer adjustment system here, which is designed for importing games from 4.6 and potentially for 5.0. Probably most of you don't use this, but there was an issue where using the arrow keys you could accidentally flick one of the pointers and change it, and it would basically break the game, and you'd have to load it in from a previous save. So I've changed it now so that rather than the arrow keys and the plus and minus, it uses control with 1, 2, 3, 4, and control 1, 2 for plus minus 1, control 3, 4 for plus minus 10. So that should stop it from causing any more issues. Now the other thing that I've done here is to set up the situation where we can now rather than adjust the sprite pointer, which never really needs adjusting because you can just add or remove sprites, I've set it up so that when you select the sprite pointer you can adjust now to create some space for some code. But I'm going to come back to that a little bit later. First I'm going to show you the actual code that we want to implement, and then I'll explain how you go about reserving the space to fit it in. And this method has all the advantages of the character set and none of the disadvantages of loading it in to higher memory. Okay, so let's take a look here. I've got a little demo of a simple square that I'm moving around. Now what I want to do is I want this square to be, say, red. So the obvious and straightforward thing to do here would be to just write in here sprint 2. And if I do that, you'll see it works, but you can also see, if I just stop here, if you look at the edge here, you'll see there are some issues there with a little bit of flicker. Now the reason for that, if it isn't obvious, is that the color is being added before the sprite has moved, because obviously here you've moved the sprite and the color is not lining up exactly with the sprite, and as a result you're getting that flicker. So that's the reason why we need to have the color that we want here at the end of the code. And of course if we do that, it no longer causes a problem because the color is matched up to the new coordinates of the sprite. Now if I then go over and put this background code color here and add it, you'll see immediately though the problem that most of us are aware of when we've got a sprite that's moving over a background. It tends to paint it over anything that's not the matching color. Now the standard solution to this, of course, is to put spriting 7 here, and this will basically put the white color over the position where the sprite previously was, and of course that will now solve the problem. But as you can see here, there are two issues still with this. One, of course, we're still getting that flicker there, which I'm sure most of you will be familiar with, which is a little bit unsightly. And in addition, this will only work with blocks if it passes over a block which is a white ink. If it passes over any other color, then it will simply paint it white, and we haven't really solved the problem. So let's take a look now at how we can actually solve this problem. We're going to basically load in an alternative version of the sprite ink command with an additional piece of code which checks what type of block is being colored. And what will actually happen here is that it will only paint the background type 0 type block. And this should mean that we can, if we want to have background blocks or ledges or anything like that, then they will maintain their designated color and the spriting won't affect it. But the sprite will still be colored when it's passing over the normal background. And this should help us to eliminate most of the problems that we've seen. So what we're going to do is load a binary as before. We don't need to go to the character set, and I've got it here pre-made. It's 36944 CSPR, and you can see here it's 91 bytes. But I'm not going to load it in right now because I haven't reserved space for it. I'm going to show you now how we do this. We go down to the sprite marker there, S for sprites, here. And what I want to do is add 91 bytes, but in this point in the video I've made a small mistake, and as you can see what I've actually done is I've added 901 bytes because we have increments of 1 and increments of 100. So obviously what I should have done was reserved 91, but I've reserved 901, so don't make that mistake. Nevertheless, we can continue because obviously we have plenty of memory, and we've got 901 bytes reserved now. I can put plenty of code in there if I want. So the next thing that you do, once you've reserved that space, is you need to basically go to the editor screen, edit screen menu here, option, just go to it and then exit, because that will basically sort out the memory and reorganize everything so that everything is in place. And we've then got our reserved memory, which is of course 901, should have been 91, but everything else is intact and stable. And as you can see here, the game is running as normal. The demo, I should say, not really a game, is it? But anyway, so we've got the space reserved, the memory is all organized. We can now load in this data here at 36944, just like that, and that's our code now loaded in and ready to be activated. And in order to activate it, what we have to do is load up this poke file, and I'll make both of these available on the Dropbox link. So basically you go here, and this is called new cspr.poke. This is, and what this basically does is it changes the routine, the current AGD sprite routine, and it points it instead, it tells it to go to our code instead. So our code is now replacing the original sprite inc command, and this means that we can add extra code and change the commands without disrupting the overall structure of AGD. So now that that code's in there, we no longer need to put Spring7 in here. Let's see what happens, and oops, well, we still have our problem of the overpaint, but it can now be solved because block 1, as you'll see here, it is type 0, and that's why it's getting painted on. But if I change it to type 254, for example, here, and this would be the same if it was a wall or a ledge or anything else, it won't get painted on. And as you can see here, there you go, the sprite is no longer affecting that part of the screen. So this basically allows us to design our screens in such a way that the colors, we can have the sprites to be any color and they will all work. The one thing that needs to be said, of course, as well, is that all of your sprites now need to have a spriting command, because it is still coloring the background, and if you have a sprite without that, it will inherit the color of the whatever's gone over the background previously. So every sprite now needs to have a spriting command at the end of its script. But I think that's a pretty small price to pay for a routine, which now means that all your sprites can be multicolored without any flicker and without really having any impact on the background. Now obviously this method isn't quite as good as an attribute buffer, but it only uses, as we've seen here, 91 bytes, whereas the attribute buffer takes up something like about 800 or so. So the other good advantage, of course, is where we've stored the data, the memory is correct, so we know how much memory we've got left. Nothing is in higher memory, so we don't need full memory save, and I've actually removed that from this version, so we don't need it anymore. And it will save off in the tap as part of the game itself, so it'll just be a single tap and with no gaps, and it will work perfectly and run exactly as though it was an integrated part of AGD itself. So all of those things make it, I think, a very good and simple method for adding more color to the games. And I'm going to be using this trick extensively in future videos to show you how to implement more additional code, some of the other tricks I've done in the past, which can be done more simply and more easily now. Okay, so that pretty much wraps it up, I think, for this one. If you have any questions, you can visit the Facebook page. I'll be happy to help, and hopefully this is going to mean more colorful games for the AGD community. Okay, great. Well, as always, keep enjoying AGD, keep enjoying the Spectrum, and of course, happy coding. Bye bye.